We've been talking about some terms and learning about polynomials that are very similar but have some subtle and distinct differences. Now we need to really understand the differences and similarities between these terms to better understand what we're talking about when we talk about polynomials. So these terms are factors, solutions, x-intercepts, and zeros. Let's look at the polynomial f of x equals x squared plus 6x plus 5. Now this polynomial is in standard form. Let's get it in factored form by factoring this quadratic. So I'm going to have two binomials. X is going to be in the first spot, and the two numbers that multiply to be 5 but add up to be 6 are 5 and 1. These are the same function written in two different forms. Now what I want to determine about this function are its factors, its solutions, its zeros, and its x-intercepts. Now the factors are easy because they're just the factors from the factored form of the polynomial. So the factors are x plus 1 and x plus 5. To get the solutions, we set each factor equal to 0. So my solutions are x equals negative 1 and x equals negative 5 because if I write x plus 1 equals 0, x will equal negative 1. And I don't mind that you do this calculation in your head. The zeros are the same as the solutions, so they will be x equals negative 1 and x equals negative 5. Now it's possible to graph this polynomial. It's a second degree polynomial, so it has those same end behaviors, and it has a positive leading coefficient, so it's going to point up. Now we look at our graph, and we say, those x-intercepts appear to be at the points negative 1, 0, and negative 5, 0, right where the zeros said that they should be. So let's kind of rehash the differences here. X-intercepts are points like you see on a coordinate plane. Zeros and solutions are little phrases that start with x equals, and factors are these terms in parentheses that are irreducible or linear and make up the factored form of the polynomial. So let's try another example. F of x equals x squared plus 7x plus 10. The factor, we need to factor it to get it in factored form, and the two numbers that multiply to be 10 but add up to be 7 are 2 and 5. So the factors of this polynomial are x plus 2 and x plus 5. Now we want to know our zeros and our solutions. If x plus 2 equals 0, then x equals negative 2, and if x plus 5 equals 0, x would have to equal negative 5. Now zeros and solutions are the same, and I need to write my x-intercepts. So the x-intercepts, where it crosses the x-axis, are going to be the points negative 5, 0, and negative 2, 0. Now look at the difference in the signs here. Zero solutions and x-intercepts all have numbers with opposite signs than what appears in the factors. This is sort of an artifact of the fact that we set the factors equal to 0 and then solved them before we went on and wrote these other items. It was necessary, and this is sort of the effect that it creates. Alright, let's try one from the other direction. If I give you the x-intercepts, you should be able to tell me lots of other things about the function. So the x-intercepts of this function are negative 3, 0, negative 1, 0, and 2, 0. And we want to figure out what were those solutions, what were those zeros, what do the factors look like, and what could that original function have been, all from looking at the x-intercepts. Now we know that the solutions are what we see in the x-intercept. So the solutions to this function are x equals negative 3, x equals negative 1, and x equals 2. Zeros being the same thing are also going to be negative 3, negative 1, and 2. Now, remember that the signs are different when we write it as factors, and also remember that when you set a factor equal to 0, you will get the solution. So we'll write the factors as x plus 3, x plus 1, and x minus 2, so that when we go to solve them, we would end up with the proper solutions. Once you have the factors, it's trivial to write the function because that's just going to be its 3 factors. And if you wanted it in standard form, of course, you could multiply it all the way out.